Hello everyone, welcome back to our channel. So today we are going to discuss another problem from the CSES problem set, that is the maximum XOR subset. Let's see what the problem is saying to us and how we can solve this. Before starting, I want you to please like and subscribe the channel for more solutions related to DSA and problem set. So without wasting time, let's dive into the problem statement and then to the logic part. So the problem statement is saying, given an array of n integer, your task is to find the maximum XOR sum of a subset. With size of an array and array elements, we need to find the maximum XOR sum of the subset. Okay, so let's understand what the problem statement is actually saying us. So problem statement is saying we have an array 1, 6, 12 and 6. Yeah. So we need to find the maximum subset XOR. So maximum sum of a subset. So maximum sum of a subset would actually be XORing all the elements in a subset. So if I am considering 6 and 12 as to be a subset and I need to find the sum of XOR, then it would be the XOR of 6 and 12 only. This would give me the answer. Now I need to find the maximum. Let's see how we can find the maximum. First, if we consider a naive approach that we follow, that for if there are n elements in an array, and suppose be an array of n elements, then total number of possible subsets would be 2 to the power n, and then for all the possible subsets, I'll find which gives me the maximum XOR of all possible subsets. So this would give me a big of 2 to the power n complexity, and we know that this is not an optimized solution, as this would be failing for a very small, even for a very, if n is equals to 20, then it would actually go into a very large number, and we are and this solution would not be get accepted. Now let's see how we can actually optimize this solution. I hope you have visited my previous problem, maximum sum of XOR subarray, that we have discussed in the previous video. We would actually be using a similar kind of approach in this problem as well. So I want you to please check out that video and understand what the trie data structure is, how we have used trie in that, because we would be using the same data structure here as well. So we would be taking 2 steps to actually understand the logic behind this. So the first logic that we would be using is, let's define a prefix of I, which is equals to XOR of all the elements from 0 to I, and prefix, gives me prefix of, ARR of 0, XOR ARR of 1 till XOR of ARR of 1. Now, second thing is, if I need to find a XOR of a subset from I to j. Let's suppose we have an array and we need to find the subset starting from I and ending at j. Whether isn't it would be the XOR of prefix till j minus 1 XOR prefix of I minus 1 till j. Isn't it would be something like this? Let's see how we actually came into this observation. Okay, so we know that prefix, let's suppose from I to j, we know that prefix of j would actually be ARR of 0 XOR ARR of 1 till ARR of j, and for similar for I, it would go till ARR of I. Now when I would be XORing this both, I would be doing ARR of 0 twice, and we know that XORing, by doing the XOR with A, like A XOR A, would actually give me 0. So this would actually be 0 because these are all will be the repeating elements. So all the distinct elements would be ARR of I. Like if I see consider them, so I would actually land up getting from ARR I to ARR of j, which would be all the distinct elements, and this would actually be the XOR of subset from I, like this would be I minus 1, I would say this is I minus 1 from I to j. I hope you have got this part, because this is a very crucial part in understanding how we are actually coming to this solution. Now once I have understood this, now we can actually see how we can make a using a trie data structure. We could optimally find the max from this I to j, for all I to j, if we have actually got the prefixes. Now let's move to that part. Okay, let's understand this with actually an example, with the test case only that is given to us, 1, 6, 12 and 6. Okay, so initially a trie would be 0, so we would be inserting 0 in our trie. Next thing would be, we have an element 1, and initially our prefix of, and this would our prefix XOR would also be 0. Now when we are moving towards an element 1, our prefix XOR would actually be 1 XOR 0, so which would be 1. And now we will insert 1 to trie, and then we'll be finding the maximum XOR with 1 by all elements in trie. So it would be XOR of 1, 0, and that would be 1. So maximum XOR till 1 would be 1 only. Now when we are using 6, when it's the time for 6, our prefix would be 1 XOR of 6, which would be giving me 7. Then we will be inserting 7, and max would be for 7, 0, like XOR of this both, because 0 and 1 are in trie, and XOR of 7, 1. Doing XOR with these both elements, for 7, 0 we would actually be getting 7, and for this we would be getting 6. So our max would be 7. And now when we go for 12 and then for 6 again, our final answer would actually be 13. And I guess this is what the answer that we want. Yeah. And now let's see how our trie data structure would actually be helping us in finding the max, how we are making the trie out of it. So initially we have 0, so let's suppose we have a root. We would be inserting, let's suppose for trie we have 0, 1 and 7. Let's consider 4 bits for now. For 1 we would be having this, and for 7 it would be this. We are finding the max when we insert 12, like for the case that we are discussing in 1, 6, 12 and 6. So for 12 we would be doing the XOR with prefixes 7. So we are actually doing the XOR with 7. So here 12 XOR 7 would actually give us 11. And now we would be inserting this 11 into our trie. Insert 11 to trie and then finding max with 11. So finding max with 11 would be 11 0, 11 1 or 11 7. So let's see how a trie first of all would be. So with the root I am going to 0, then 0, then pushing 0 and 0. This is how our trie, we would be making a binary trie. Okay, so I'll make the trie again. Just a sec. So let's make a cleaner trie with this and another. Okay, so this is our root. So we will be inserting 0 first. This is how our 0 insertion would look like. Now we are inserting 1, so it would be like a single node would be here. Now we are inserting 7, so it would be 1, 1 and 1. Now we are inserting 11, so 11 is actually 1, 1, 0, 1. Sorry, it would be 0, 8, 2, 10 and 1, 0, 1, 1. So inserting it would be 1, left 0, then right 1, then again right 1. Now for actually finding the max for this 1, 0, 1, 1, we have to find the opposite bits for starting from this particular bit. So if I found the 0 for this, 1 for this, 0 for this and 0 for this, then my XOR would be the maximum XOR I can say. So let's see how we can find that. So for 1, I'm actually finding a 0. So I got a 0 over here. So I can say I've got a 0. Now for 0, we need to find the 1. But so do we have a 1? Yes, we do have a 1. So we'll say we got a 1. Now for next, we are finding a 0. So in this part, do we have a 0? No, we just have a 1. So we'll push 1 here. And for the next also, we just have a 1. So we'll push here. So with finding the max with 11, would actually find out this. So this would be 1 1 and this would give me 12. So you can check with this also. The maximum XOR that we would get by XORing with these three elements would be 12 only. Let's check it once. With 11 XOR 0 we got 11. With this we got 10 and with this we got 12. So our max is 12 only. So this is how trie data structure would be actually helping us in finding the XOR very easily, and this would actually reduce our time complexity to big of n into log operations of maximum element of ARR, because would be bitting this into trie, and n is because we are inserting over all the n elements once. And so this is how our time complexity will actually reduce from big of 2 to the power n to this, like approximate this complexity. Now let's see how the code is being written for this. So we have initialized a trie data structure with the proper insertion of how we are inserting. Our n is a large number, so we have defined the max bit has to be 30. So we are inserting into the trie and deleting the trie as well. Now first, when I have taken the input, we are finding the max XOR subset. So in max XOR subset, we are inserting the 0 first, and then we are maintaining the prefix XOR. So our prefix XOR will be XOR with the num. We are inserting that prefix XOR into trie and finding the max XOR. Now in the max XOR, we are starting from the most significant bit, and then we are finding the opposite bit, whether it exists in the our table, our tree or not. And then if it exists, we are adding that into the maximum XOR by adding all the bits and then moving to its children node. If not, then we are actually considering that bit only. So this would actually help us in getting the max XOR that we are expecting. Now let's try to submit this problem once. Let's see if it gets submitted or not. Test.cpp. Yeah. Let's check and submit this problem once. the answers get submitted. So this is how our maximum XOR subset problem would actually be. I hope you have understood this problem. If you have any questions regarding this, please drop me a comment below, and I would be highly into solving those your queries. And let me know in the comments what are the next topic or next question you want me to solve and provide you the solution for. And see you in the next video. Please like, share, and subscribe the channel. Thank you.